In this lesson, we'll use percent composition data to determine the empirical formula of a compound. There are no other learning outcomes to add, so let's begin. The empirical formula is the simplest whole number ratio of atoms in a compound. The actual formula for a compound can be the same as the empirical formula, or it can be a whole number multiple of the empirical formula. We'll discuss these molecular formulas in the next lesson. For now, let's examine some chemical analysis data to determine an empirical formula. Suppose that a 20-gram sample of a hydrocarbon is found to contain 8.00 grams of carbon, 1.34 grams of hydrogen, and 10.7 grams of oxygen. To determine the empirical formula, we convert each of these masses to moles using the molar masses of each element. This gives us the formula C.666, H 1.33, O 0.669 that doesn't look like any formula we've seen to date. To fix this, we'll divide each of these numbers by the smallest number, 0.666, which gives us C1H2O1, our first empirical formula determined from an elemental analysis. While dividing by the smallest decimal subscript often works, sometimes it's easier to multiply the subscripts by a whole number to get rid of the decimal. From our last example, we see that 0.666 is roughly 2/3, 1.33 is 1 1/3, and 0.669 is also about 2/3. If we multiply each of these decimal numbers by 3, we get the correct ratio, CH2O. Imagine that we have 4 AB compounds with the following ratios. Using what we've learned, can you identify the empirical formula for each AB compound? Keep in mind that it may be easier to multiply by a factor to clear the decimal subscripts, especially if the lowest number is 1. In this example, we're asked to identify any empirical formulas. Think back to the definition. Do any of these formulas show the lowest whole number ratio of elements? In fact, none of these are empirical formulas, so take a minute to determine the empirical formulas for each compound before continuing. Tying this back to our last lesson, suppose that you're given percent mass composition data. How do you convert this information to an empirical formula? The easiest way to accomplish this is to assume you have a 100-gram sample. That turns each percentage into a gram value, so 25% by mass of carbon becomes 25 grams of carbon out of a 100-gram sample. From there, convert to moles, divide each mole subscript by the smallest number of moles, or multiply by the appropriate factor, then report the empirical formula. Here's one for you to try. What is the empirical formula for a compound that is 43.7% phosphorus and 56.3% oxygen? First, assume you have 100 grams of the substance. This gives you 43.7 grams phosphorus and 56.3 grams oxygen. Convert these masses to moles, then divide or multiply as needed to get the empirical formula. It's important to realize that ionic compounds are identified by their empirical formulas, the lowest whole number ratio of elements in a formula unit. Exceptions to this rule include certain polyatomic ions, such as O2 2-, Hg2 2+, C2O4 2-, and S2O8 2-, that come packaged that way and cannot be reduced any further. Covalent compounds, which we'll discuss in the next lesson, use empirical formulas to determine their molecular formulas using the molar mass of the compound. As always, I'll leave you with the parting thoughts of the authors.